For the last example in this section, we're going to look at the area of a surface of revolution. And it says if a smooth curve where x is defined as f of t, y is defined as g of t, t ranges between a and b. If it's traversed exactly once, so we're not going to overlap itself, as t increases from a to b, then the areas of the surfaces generated by revolving the curve about the axes are as follows. So depending on whether we're revolving about the x or the y-axis, we're going to use either the first or the second formula. They're very similar. The only difference in the two formulas is having a y or an x here. If we're revolving about the y-axis, this is going to be, or sorry, if we're revolving about the x-axis, we're going to have a y inside the integral. If we're revolving about the y-axis, we'll have an x. Otherwise, they're identical. But notice that you will have to differentiate your x and your y for both of them. So we are given this example here. Find the area of the surface generated by revolving x equals t plus the square root of 2, y equals t squared over 2 plus the square root of 2 times t minus the square root of 2. It's a bit of a mouthful. And t is going to go between negative square root of 2 and positive square root of 2. And we want to revolve that about the y-axis. So we're using the second case here. So we're going to take it, this way. Now, for this formula, I need to find dx dt and dy dt. So for dx dt, it's just going to be 1 because the square root of 2 goes to 0. That one's easy enough. Now, dy dt, we're going to have 2t over 2, so that's just t, plus the square root of t, and again, this goes to 0. So nothing too complicated. Now that we have that, we can go to our formula. So the surface area, our t values go from negative square root of 2 to positive square root of 2. And we've got 2 pi times x, which is t plus the square root of 2, times the square root of dx dt squared, so that's 1 squared, plus dy dt squared. So that's t plus the square root of 2 squared dt. So I need to do a little bit of cleaning up inside the radical there. I'm also going to change one thing here in front. I'm going to take this 2 and I'm going to multiply through the parentheses. And the reason I'm going to do that is going to become apparent in just a few minutes. But it's mainly because I've worked this problem before and I know what's coming. Okay, so I just distributed the 2. Inside the radical, we have got 1 plus t squared plus 2 times the square root of 2t plus 2. And you might be thinking to yourself, well, it's kind of ugly inside that radical, and it is. But it's okay. We're going to be able to do a u substitution. So let me go ahead and rewrite this. So putting the terms underneath the radical in a little bit better order and combining like terms, we end up with t squared plus 2 square roots of 2t plus 3. So you might be now seeing why I decided to distribute that 2 over here. And if you don't see it yet, that's fine. You'll see it in a second. So what we need to do now is do a u substitution. So u is going to equal everything inside that radical. So I'm going to let u equal t squared plus 2 square roots of 2t plus 3. And then du is going to be 2t plus 2 times the square root of 2 dt. And that's why I multiplied through by 2. So we've got everything we need here to do the u substitution. The only thing that's not needed is the pi, which I'll move in front. Now, because I'm doing a u substitution, I'm going to go ahead and change the upper and lower bounds here. If t is equal to negative square root of 2, I end up getting a u value of 1. So we basically have, this would be 2 minus 4, yes, plus 3. So that would give us a 1. And if t is equal to the square root of 2, we're going to get 2 plus 4 plus 3, so 9. So I have got the square root of u, or u to the 1/2 power, du, because all of this and this together make my du. So that's fairly easy to integrate. It's going to be u to the 3/2 over 3/2, or 2/3 u to the 3/2 power. And we're going to evaluate this from 1 to 9. So starting with the 9, the square root of 9 is 3. 3 cubed is 27. And now the 1, the square root of 1 is 1. 1 cubed is 1, so I just get 2/3 times 1. So we have pi times 54/3 minus 2/3. 54 minus 2 is 52, so we have pi times 52/3, or 52 pi over 3. And we are done.